Hello friends, today we will discuss the next content of chapter Combustion in SI engine. Previous lecture we studied stages of combustion, ignition lag, flame propagation and factors affecting the flame speed. Now today's lecture we will discuss abnormal combustion, auto ignition and pre-ignition and influence of engine design and operating variables on knocking if time permits. So we will start with the abnormal combustion in SI engine. So in previous lecture we discussed that the combustion is roughly grouped in two parts. One normal combustion, second abnormal combustion. Normal means the knock free combustion and abnormal combustion means the knocking combustion. So as we know that in case of the normal combustion, the flame is initiated by a spark plug and the spark travels uniformly over the combustion chamber. However, under certain conditions the combustion process deviates from the normal conditions. Under certain conditions the combustion process deviates from the normal, causing loss of performance and damage to the engine. So as in case of normal combustion, spark traveling is uniform and thereby the complete mixture is to be burnt uniformly in the combustion chamber and we can get the normal pressure rise or uniform pressure rise in the indicator diagram. So this phenomena of abnormal combustion is called as knocking or detonation. This phenomenon of the abnormal combustion is called knocking or detonation in SI engine. So the effect of this abnormal combustion are loss of engine power, pre-ignition reappears, as well as it causes the increase in the different part of wear of the different engine parts, namely crankshaft, piston, cylinder head, combustion chamber parts. So many that parts were come under the this knocking. Because of that it gets the wear. So we'll discuss what actually happens in the knocking and the normal combustion. So here the first figure you see the normal combustion means the combustion chamber, that is a knock free combustion chamber. So in SI engine during normal combustion the flame is initiated and this flame front produced by the spark is spread uniformly inside the combustion chamber. Here it uniformly moves and it going to consume the unburned mixture uniformly and thereby at last it reaches to the D and thereby the normal pressure rise you can going to be observed in the normal combustion chamber, because heat release due to combustion increases temperature of the burn mixture, then the unburned mixture comes in contact with this burn mixture and thereby its temperature pressure increases, then next unburned mixture come in contact with this burn mixture. Likewise the process is uniformly proceeds in the combustion chamber and we can get the uniform pressure rise in the indicator diagram. But what actually happens in the knocking or this combustion chamber with the detonation? So here A is flame front that will be produced by the spark plug is moves uniformly by consuming the unburned mixture and thereby this consumed unburned mixture consumes the further unburned mixture which is in contact with it and thereby flame front moves in a combustion chamber. But at the same time the unburned mixture which is farthest from the spark plug is reaches to its self ignition temperature. So here flame front is showing at B dash. Here it is shown B dash and the unburned mixture which is farthest from the spark plug, that is C dash, it reaches to its self ignition temperature and it remains at that value during the ignition lag period, means how much ignition lag is to be provided during that period it remains for that self ignition temperature, and because of that the spontaneous ignition or uncontrolled auto ignition is going to be occurs at various locations inside the combustion chamber, and because of that it causes the abrupt pressure pulses inside the combustion chamber it causes the audible noise in the combustion chamber. So this phenomenon is called as knocking or detonation in SI engine. So what actually happen in normal combustion, the end charge CC dash. So here the BB dash, the end charge CC dash, here BB dash, here the BB dash, that is the flame front, is going to uniformly move throughout the combustion chamber and it going to burn the mixture, unburned mixture uniformly. But in this second case, in the knocking, means knocking that combustion chamber, what happens? The end charge CC dash is reaches to its auto ignition temperature or self ignition temperature, and it remains at that temperature during the ignition lag period. It remains at that period for ignition lag period, and then it auto ignites. And causing the knocking with abrupt pressure pulses and audible noise. And because of this knocking, as this end charge CC dash, which is shown here in second figure, CC dash is going to be auto ignites, it creates the additional flame front along with the main flame front, which is produced by the spark plug, and these both flame front are moves opposite to each other. Means the flame front, additional flame front that is produced by the end charge CC dash is moves opposite the main flame front, and these both flame front are collide with each other, and thereby it creates the abrupt pressure pulses and audible noise. Means severe pressure pulses are formed and which vibrate the engine cylinder, and thereby it causes the wear of different engine components. So how we have to avoid this knocking or detonation? So to avoid the knocking or detonation, it is desirable to use the fuel having the high auto ignition temperature. It is desirable to use the high auto ignition temperature or high self ignition temperature, and the fuel must be having the longer delay period or longer ignition lag. Then and then only this fuel is going to avoid the knocking in case of SI engine. So underline this sentence, that to avoid the knocking in SI engine, we desire high auto ignition temperature of fuel. Underline high auto ignition temperature of fuel and longer delay period or longer ignition lag. Underline. So these two factors are very much important to avoid the knocking in case of SI engine. So these vibrations are going to create the wear of the different parts of the engine. It causes the failure of the engine. So knocking is not again desirable. So next we see the auto ignition. What is the auto ignition? So auto ignition, that is a mixture of fuel and air, can react spontaneously and produce heat by chemical reaction in the absence of flame to initiate the combustion or self ignition. So auto ignition means the fuel and air can react with each other spontaneously and produce heat by chemical reaction in the absence of flame. Underline in the absence of flame, as we studied and we discussed in that previous article, that the end charge is going to be exceeds its self ignition temperature, is going to be exceeds its auto ignition temperature and remains at that value for ignition lag period. Means the end charge is going to auto ignite in the absence of flame. In the absence of flame, that is known as the auto ignition or self ignition. So this type of self ignition in the absence of flame is known as auto ignition. There is no any flame, but till the charge is react spontaneously. The charge means the air fuel mixture is going to react spontaneously and produce the heat. So the pressure and temperature is abruptly increased during the auto ignition. Because of that, the sudden release of chemical energy. Because of sudden release of chemical energy. So this auto ignite leads to abnormal combustion. Auto ignite leads to the abnormal combustion means auto ignites causes the detonation. Auto ignites causes the knocking, and which is undesirable because it having the bad effect on the engine performance. Also the life of the different engine components to be reduces because of this auto ignition, because of this abrupt pressure pulses that is produced in the knocking. So in addition to this knocking, which puts a limit on the compression ratio which an engine can be operated, which directly affect the engine efficiency and output. So mainly underline again, this knocking puts limits on the compression ratio. So why compression ratio? We are going not using the higher compression ratio in case of SI engine because of the auto ignition, and because of this auto ignition, the auto ignition, it leads to the abnormal combustion, or it leads to the knocking or detonation. Getting, because of that, higher compression ratio in case of SI engine is not desirable. Next, preignition. So preignition is the ignition of homogeneous mixture of charge as it comes in contact with hot surfaces in the absence of spark. Getting, again, but here flame is absent, but the end charge is must be come in contact with the hot surfaces. It is inside the engine cylinder. Then and then only pre-ignition will be occurs. So auto ignition may, during the auto ignition, what happens? It going to create the high pressure pulses. It going to release the high chemical energy in the form of heat, and this heat energy is going to overheat the different parts of the engine, namely that is the spark plug, exhaust valve, cylinder valves. Getting, and it remains so hot that the temperature is sufficient to ignite the charge in a next cycle during the compression stroke. Means suppose in first cycle, if auto ignition will be occur, so due to this auto ignition, different parts of the engine, namely spark plug, exhaust valve or cylinder valves are becomes the hot, and because of that the temperature is sufficient to ignite the charge in a second cycle and during the compression stroke, and because of that the spark occurs spontaneously on its own, and this causes the pre-ignition of the charge because of the hot surfaces. And why these hot surfaces are there? Due to the auto ignition in a first cycle. Getting, in a first cycle. So pre-ignition is initiated by some overheated parts such as spark plug, electrodes, exhaust valve, metal corners in the combustion chamber, carbon deposits or protruding cylinder head gaskets, rim. Likewise different that parts inside the combustion chamber which are going to initiate the pre-ignition. So again, pre-ignition also caused by the persistent detonating pressure shock waves. Pre-ignition also causes the shock waves. It is also not desirable. So how pre-ignition reappears? So because of the auto ignition, the pre-ignition is reappears. Getting, that is the one disadvantage of the abnormal combustion. It is the one disadvantage of the abnormal combustion, that recurring the pre-ignition. Means pre-ignition, why it is appear? Due to the auto ignition. Why auto ignition is there? Due to the abnormal combustion. So by that way, pre-ignition is also not desirable. Getting. So effect of detonation. So now we will discuss which are the different effects of the detonation in the SI engine. Because already we have discussed that it is not desirable, it causes the loss of engine power, it causes the wear of the different engine components, failure of the different engine components. Well, now see the different that harmful effects of this detonation. So first, noise and roughness. So knocking produce loud pulsating noise and pressure waves, and these waves which vibrates back and forth across the cylinders. Getting, so these waves are abrupt and they will be moves back and forth, means across the engine cylinder, and the presence of this vibratory motion cause the crankshaft vibrations and engine runs rough. So that is a one effect of detonation. Second, mechanical damage. So high pressure pulses, high pressure waves generated during the knocking can increase rate of wear part and combustion chamber. Also severe wear and tear of piston crown. Erosion means wear and tear of piston crown, cylinder head. Getting, pitting of inlet and outlet valves. Pitting means localized corrosion. It causes the corrosion of inlet and outlet valves, and it results in a wreckage. Wreckage means destroy of the engine. Getting, it will results in a wreckage of the engine. So it is difficult to detect the knocking noise, and hence corrective measures should be we have to provide to avoid the knocking. Getting, so first, then detonation is very dangerous in engine having high noise level. In small engines, the knocking noise is easily detected and the corrective measures can be taken. But severe detonation may persist for long time, which may ultimately result in complete wreckage of piston. Third, carbon deposits. So detonation results in increase in carbon deposits. Because of the detonation, the carbon deposit also increases. Next, increase in heat transfer. So knocking is accompanied by an increase in the rate of heat transfer to the combustion chamber walls. So heat transfer is going to be increased due to the knocking towards the combustion chamber walls. And why this heat transfer is to be increases? So the two reasons. The minor reason is that maximum temperature in a detonating engine is about 150 degrees centigrade higher than the non-detonating engine. Means temperature is will be higher in case of detonating engine compared to the non-detonation engine due to this uncontrolled combustion, due to the rapid combustion of the engine of this fuel. Second, the major reason for increased heat transfer is that scoring away. Scoring away means it is going to clean away. It is going to be clean away the protective layer of inactive stagnant gas of the cylinder walls due to the pressure waves. Stagnant means not flowing. So not flowing gas that will provides the protective layer, and this protective layer is to be clear by these high pressure waves, and because of that it increases the heat transfer rate to the cylinder walls. Getting. Fifth, decrease in power output and efficiency. Due to increasing the rate of the heat transfer, the power output as well as efficiency of detonating engine decreases. And sixth, preignition. Already we have discussed that it will reappears requiring the preignition due to the auto ignition. So increase in the rate of heat transfer due to the valves cause the local overheating of the different parts of the engine, like spark plug, like exhaust valve, like the head gasket head, so many or metal corners, and this causes the recurring of the preignition. Preignition is going to be reappears in that case. Getting. So in this manner, these are the harmful effects of the detonation on the engine. Okay, thank you. So remaining that content of this chapter number 5 will discuss in the next lecture.